Hi everyone, welcome to the video. Today I'm going to walk you through how to use Taguchi design of experiment approach using the Excel template I created. This tool allows you and your team to run a powerful screening experiment without needing software like Jump or the Minitab. I regularly use these statistical tools for my experiment. However, not many people will have access to those specific tools, so I created for those. Since I do believe although Taguchi design is classical method, still powerful today, compared to the OFAT, one factor at a time. In this video, I'll cover 4 key parts. 1. How to assign variables in L16 table. 2. How the ANOVA and pooling process works. 3. How to interpret main effects. 4. And how to detect interaction using graphs. So let's get started. Let's suppose you are designing a new car with a better fuel efficiency. You are trying to screen 2 types of each variables, changing types for gear, tires, shafts, and so on. Each level will have type 1 and type 2. You are repeating the test and entering those data in the last 2 columns in the Excel table. The L16 orthogonal array has 15 available columns, but here's an important tip. You don't need to use all 15. In fact, I recommend assigning up to 9 main factors and saving the rest for the interaction terms like AB, AC, AD, and so on. In this template, I've highlighted in yellow the columns I recommend using. These are mostly single term, 3-way, and 4-way interaction columns. These higher order interaction columns are less likely to show strong effects, so they are great placeholder for main effects if you think your system is relatively simple. By doing this, you still leave space for testing 2-way interactions, which can reveal important relationship between your key variables. You can choose to repeat your experiment or not, but I highly recommend replicating trials to improve your statistical accuracy, especially for p-values in ANOVA. Once your experiment is complete, the next step is ANOVA, which analyzes which factor truly impacts your results. But before running ANOVA, this Excel tool performs a pooling process. You can enter a threshold percentage, say 5%, into this cell here. Then any factor or interaction with a contribution less than that will be pulled into an error term along with repeat error and pure error. This improves the accuracy of your F ratio and p-value calculations. After pooling, the template shows p-value, and this cell will turn green if the p-value is under 0.05, meaning it's statistically significant. In this dummy example, factor ABCD and the interaction AB, AC, and BC are all significant, each with the p-values below 0.05. Next, the tool automatically generates main effect plots for each factor. These simple line graphs help you see which level 1 or level 2, produces a higher average response. For example, if factor A has a higher average at level 2, that's the better settings for your desired outcome. These graphs are especially helpful for screening out less important variables or picking optimal levels in a follow-up testings. Finally, one of the most powerful features of this tool is interaction graphs. Each graph plots 2 factors at once. If the lines are parallel, there's no interaction between the two. But if the line cross, that's a clear sign of interaction, meaning the effect of the one factor depends on the level of another. These interactions are easy to miss without a systematic DOE approach. So even if your main effects are clear, don't skip the interaction plots. They might reveal something very important. So that's how my Excel-based Taguchi DOE works using the L16 design as an example. You can run screening experiments, perform ANOVA, and interpret result, all without specialized software. If you found this helpful, drop your question in the comments. Thanks for watching.